Okay students, so today my lesson is going to be quadratic equations, right. What is a quadratic equation? What do you mean by a quadratic equation? Right? That is an equation of the form ax squared plus bx plus c equals to 0. Right? You all have learned this for O levels also, right. Quadratic equation means an equation of the form ax squared plus bx plus c equals to 0, where this a, b and c are real numbers, right, and this a is not equal to 0. A is not equal to 0 because if a is 0, we do not have this x squared term, then this will be a linear one, right. So, a is not equal to 0, but these ones can be equal to 0. B and C, they can be equal to 0, but a is not equal to 0 and a, b, c all three are real numbers. Okay. Now, let us find the solutions of quadratic equation. Right, let us find the solutions of a quadratic equation. That means I am going to find x. Ax squared plus bx plus c equals to 0. Right. Now I am going to find the value of x. I will divide all the three terms by a, right. So I will get x squared plus b over a x plus c over a equals 0 over a means 0. Divide all the terms of this one by this, right. Then x squared plus b over a. Now what you have to do is you have to subtract x, you have to find the value of x. I will take this plus c over a to other side, right, that is minus c over a. What I need to do is now I need to write down this one as a perfect score, right. Now in the completing score method you have learned that to both sides of this equation I will add b over, to make this a a perfect square. What you have to do is to form the constant term, you have to add the square of the half of the coefficient of x. Square of the half of the coefficient of x. What is it? Now half of the coefficient is b over 2a squared. So that will be b squared over 4a squared. So yes, this is the equation. I have to add that to both sides, right? B squared 4a squared. Okay. So now in this side, that means this is x plus b over 2a. So from binomial expansion, you know, x squared into 2 times b times 2a into x, you will form b over ax, and then b squared 2a squared. Okay, that is equal to, here the common denominator is 4a squared, and we are getting here b squared minus 4ac. Okay, now get the square root of this x plus b over 2a is equal to plus or minus, right, square root of b squared minus 4ac over 2a. Get the square root of both sides, right. So that is x plus b over 2a and equals to plus or minus square root of b squared minus 4ac over 2a. Here is 4a squared. Once you get the square root, you are getting 2a there. Okay, now you can observe, we can subject x very easy, right. X is equal to what? Minus b plus or minus square root of b squared minus 4ac over 2a, right. So that means you have two solutions for x. See, one is minus b plus square root of b squared minus 4ac over 2a, and the other one is x equals minus b minus square root of b squared minus 4ac over 2a, right. So that means for any quadratic equation, once you solve, you are getting, definitely you must get two answers, right. You must get two answers. So one is x equals minus b plus square root of b squared minus 4ac over 2a, and the other one is x equals minus b minus square root of b squared minus 4ac over 2a. So we call this as the roots of the equation, right. Roots of the equation, there are two roots, okay. One is this and the other one is this. So now let alpha and beta be the roots of the quadratic equation ax squared plus bx plus c equals to 0. Actually, alpha and beta are the solutions of the quadratic equation, right. So, I got alpha as this positive 1, I mean minus b plus square root of b squared minus 4ac, and beta equals minus b minus square root of b squared minus 4ac over 2a, right. So, you all can see that yeah, I am going to teach you how the value of alpha and beta, what happens to the value of alpha and beta when this b squared minus 4ac differ. Now, for example, let us take when b squared minus 4ac is a positive value, b squared minus 4ac, but the thing inside the square root is a positive number, positive value. I mean, we have numerical values here, no? So, once you get b squared and subtract 4ac, you are getting a positive value, let us say. Then what will happen? Minus b plus that positive value over 2a, and here minus b minus that positive value over 2a. So, can you understand, you will get two different values there, right. You are getting two different values. So, if it is so, we are getting, if b squared minus 4ac is positive, then alpha and beta, alpha is not equal to beta, we are getting two different values, but and alpha and beta we are getting real values, right. Alpha and beta are two distinct real, two distinct real numbers, two distinct real numbers. Okay. The answers that we get as alpha and beta, or the answers that we get as the solutions of the equation are always having two different real values. Now, when b squared minus 4ac is equal to 0, what will happen? When b squared, when the thing inside the square root is equal to 0. Okay, now this is 0, minus b plus 0 means minus b over 2a. This one, minus b minus 0, minus b minus 0 means again minus b over 2a. So, from both you are getting minus b over 2a. That means, if b squared minus 4ac is equal to 0, alpha equals beta. Then equal alpha equals beta, and that is equal to 0. Alpha equals beta, and that is equal to 0, right. So, they are, but still they will be real values, right, because you know b over 2a, but we are getting is not 0, this is minus b over 2a. Yeah, what we are getting is minus b over 2a, b is real, a is real, therefore minus b over 2a should be a real number. So, alpha and beta are two equal real roots, right, two equal real roots. I write here roots here, right, because alpha and beta we got as roots, right. Okay. Then the next condition is when b squared minus 4ac is less than 0. When b squared minus 4a is less than 0, that means when b squared minus 4a is a negative number, when it is negative. I hope that you all know that square root of negative numbers, right, square root of negative numbers are imaginary. So, minus b plus the imaginary number divided by 2a, minus b minus the imaginary number divided by 2a, right. That means, alpha and beta, the result is imaginary. Alpha and beta both are imaginary numbers, right. Here we are getting real numbers, and for this we are getting an imaginary number, imaginary roots. Right. So, we are giving a special name for this b squared minus 4ac, right. B squared minus 4ac, we are telling that it is equal to the discriminant. We call it a special name, this part we call it the discriminant, and that one we are representing using this sign delta, right. Nature of delta, nature of the discriminant, and we are this is actually a summary what I have taught earlier, right, and nature of the roots. So, we all learnt that if delta is greater than 0, if discriminant is positive, we will get two distinct real roots, and if discriminant is equal to 0, we are getting two equal real roots, right. When the discriminant is greater than or equal to 0, both these conditions satisfied means we have two real roots. That means in a sum, if they give like this quadratic equation is having two real roots, that means you have to get the inequality of the discriminant as discriminant is greater than or equal to 0. And if discriminant is less than 0, that means we have two imaginary roots. Okay, let's move to the example. In all of us, you have learned to find the solutions of this. This one actually we can write as, once you factorize, you will get x plus 1 into x plus 1 equals 0. Right. So, a product to be equal to 0, right, a product to be equal to 0, either both of them equal to 0 or at least one of them equals to 0. So, I will get that x plus 1 equals 0 or x plus 1 equals 0. Once I solve this one, I will get x equals minus 1 or x equals minus 1. So, you all can observe that we are getting two equal real roots. We are getting two equal real roots here, right. If you get two equal real roots, that means discriminant should be equal to 0, right. Okay, let us check whether this discriminant is equal to 0. Right. What is the discriminant? B squared minus 4ac. B squared. Now here we have ax squared plus bx plus c. What is our b? 2. 2 squared. That is 4. Minus 4ac. 4 into a means 1 here. 1x squared. 1 and c also 1. 4 minus 4 into 1 into 1. 4. 4 minus 4 means 0. Can you understand now? That means when the discriminant is equal to 0, we can tell that it is having two equal roots. That means, right, without even solving the quadratic equation, just once you write b squared minus 4ac and find its value, and you can tell whether the quadratic equation have equal real roots, two distinct real roots or imaginary roots, right. So, that is the use of this discriminant, right. So, let us discuss the 2022 A level question, this time A level question, right. They have given that P is, this modulus P is less than 1 and greater than 0. Show that p squared x squared minus 2x plus 1 equals 0. The quadratic equation has two distinct real roots. So, if they have two distinct real roots, then what is the thing that it should satisfy? Delta or the discriminant should be greater than 0. Right. So, what you have to prove is this, we have to check whether the discriminant is greater than 0. Right. So, for that let us try the discriminant. Now, what is our quadratic equation first? P squared x squared minus 2x plus 1 equals 0. Okay, first of all, let us write down what are the values of a, b, c. What is our a here? P squared. What is our b? Minus 2. Then, what is our c? Plus 1. Then now we can write the discriminant b squared minus 4ac. Discriminant is equal to b squared minus 2 squared, that means 4, minus 4 into a means p squared, c means 1, right. So, we are getting the answer as 4 minus 4p squared, 4 is common, I will take it out, 4, 1 minus p squared, 1 minus p squared, right. So, there what we have to do is, now we have to show that this term is positive, then only we can tell that this is having distinct real roots, right. You all know that 4 is positive, definitely 4 is positive. Now, how can we show that 1 minus p squared is positive? Right? How can we show that 1 minus p squared is positive? Can you observe they have given us an inequality, right. So, in this inequality, according to this one, p is something less than 1 greater than 0 means it is definitely a fraction, right. That is definitely a proper fraction, right. 0 less than 1 greater than 0. Then this is a positive value as well. Now we can You all know that once you score this kind of a 1, the value will be definitely less than 1 still, right, because it is not less than 0 now. If something is less than 0, let us say minus 2, then minus 2 is less than 0. Once you get minus 2 squared, that will be plus 4, no? So that will be greater than 1. But still now here p is greater than 0 but less than 1, that means it is a fraction. Okay. So, now for example, let us say 1 over 2. 1 over 2 squared means what? 1 over 4. No? So, this is still greater than 0, less than 1, like that, right. Then we can write modulus of p is less than 1, right. I can square both sides, therefore, I will get p squared is less than 1, right. I can take this p squared this side, subtract p squared from both sides, I will get 0 here and 1 minus p squared here. So, you can because of this you can see that here 1 minus p squared is something greater than 0, means that is positive, right. Now, this is also positive. So, positive value into a positive value, definitely our answer will be positive. So, discriminant is greater than 0, therefore, we have what, 2 distinct real roots. Okay. Okay, you all can write like this. Therefore, this p squared x squared minus 2x plus 1 equals 0 has 2 distinct real roots. Thank you all.